So the likelihood scale is fine for informal discussions of probability and likelihood, but sometimes we need to be a bit more precise than that. If you're deciding where to invest your life savings, maybe you want to have a really precise idea of how much money you're likely to earn or lose with a given investment. Or if a medical company is deciding whether or not to release a drug, they need to know exactly how effective the drug is. So in order to be a bit more precise, well, we need to be more precise in our language. So in this lesson, we're going to explain some of the terms that we use when we're talking about probability theory. We'll explain all these terms in the context of a particular example. So the example I've chosen is a die. So here's a picture of a standard six-sided die. And imagine that we're trying to analyze the likelihood or probability of various things that might happen when we roll a die. Okay, so let's explain some of the words that we use when we're talking about probability. So in this context, we might say that an experiment is a roll of the die. So we could do many experiments if we want, but a single experiment here is just a single roll of the die. So whenever we do an experiment, we have possible outcomes. So in this case, the possible outcomes are 1, 2, 3, 4, 5, or 6. Those are the possible outcomes of this experiment. The sample space is the set of all outcomes, or all possible outcomes. So in this case, we take the list of all possible outcomes we had up here, and we make it into a set. And so that set is the sample space here. So the sample space is the set whose elements are 1, 2, 3, 4, 5, or 6 in this case. An event is a subset of the sample space. So now this is a bit abstract. This is not what we usually think of as an event. But in probability, this is the technical meaning, right? But normally events are described in some kind of informal way. So let's try and make this connection a bit clearer. So to explain why we say events mean subsets of the sample space, let's look at some normal descriptions of events and write down the corresponding subset of the sample space. So I'll make a table, and on this side I'll have an event, and here I'll put the subset of the sample space. Okay, so what would be a typical event that we might look for when we roll a die? Well, we might have the event of rolling a 6. Okay, and it's easy to write down the subset of the sample space here. 6, the set with one element consisting of 6. Okay, so that doesn't seem very exciting. What about this event? Rolling an even number. So to get the corresponding subset of the sample space, we just pick out the outcomes, which are things in the sample space, that correspond to this event. And so this set would be the set 2, 4, 6. What about the event rolling a number bigger than 6? So that's a funny one, right? Because there doesn't seem to be anything in the sample space that corresponds to that event. So in that case, the subset of the sample space is the set with nothing in it, the empty set. Let's do a couple more. What about rolling a number less than 7? So remember, the sample space has numbers 1, 2, 3, 4, 5, and 6 in it. And all of these are less than 7. So they're all in the subset. So this event here is the whole sample space. In the previous example, where we had rolling a number bigger than 6, the event was the empty set. So you see, for these informal description of events, we can write down corresponding subsets of the sample space. So that's why we say that an event is a subset of the sample space. because it's easier to deal mathematically with things like this in the right-hand column here, subsets of a set, than it is to deal with informal statements in English. It's hard to make equations or mathematical statements out of informal statements. So that's what we mean by an event. One of the main problems in probability is to take an event and say exactly how likely is that event. And in later lessons, we're going to develop ways to answer this type of question. But it's interesting to look at the events that we've written down here and ask yourself this question. How likely are these events to occur? For example, how likely is it to roll a 6? How likely is it to roll a number less than 7? Well, in that case, it's easy to answer. We will certainly roll a number less than 7. How likely is it to roll a number bigger than 6? Again, that's easy to answer. It's impossible. But for events like rolling a 6 or rolling an even number, it's neither impossible nor certain. So we need some way to quantify exactly how likely events like that are.